Hello my friends and welcome back to the You Can Do TV channel.
Steel sheets at Otto Klosterman GmbH are guided through cutting and cold-forming lines, shaping components with extraordinary consistency. Cold-forming presses then bend and shape the steel, producing complex geometries without heating. This method preserves the material's strength while creating intricate parts. Operators monitor every stroke, adjusting alignment to maintain tolerances. You wouldn't expect such heavy steel to bend so precisely without heat. In the cutting stage, sharp blades trim sheets to exact dimensions, preparing them for further processing. The force applied could slice through several sheets at once, yet each cut stays flawless. Finished pieces pass through inspection to ensure exact measurements. Components are then packed systematically for shipment or assembly. Even though the process is fast, each sheet receives individual attention.
What happens when welding robots follow CAD maps to assemble massive girders without error? Robots glide steel girders into motion under SBA2 Conti plus automation. Girders arrive on automated loading stations, designed to cradle heavy steel with no manual strain. The steady way the beam settles into position shows how well the loading system handles weight. Guided by CAD-driven coordinates, the system's laser scanner scans each steel girder, mapping splice points and baseplate locations with millimeter accuracy. The handling robot then grips the girder and rotates or repositions it to face the next workstation. No human touch required. Once oriented, the first of the 4 welding robots moves in to affix splice plates and stiffeners to the beam's flanges and web. Those stiffeners slide into place like they already know where to go. Seam welders follow immediately, executing continuous welds along joint seams at speeds far beyond human capability. That weld looks so clean it might have slipped out of a blueprint. You can almost sense how steady the voltage must be to keep the bead that uniform. As one welding robot finishes, another is already prepping the next section, overlapping tasks in tight choreography of steel and flame. The handoff between robots feels almost instantaneous. Meanwhile, scanning arms verify weld quality and alignment, ensuring every beam matches CAD specs before it moves down the line. That extra verification sweep adds a quiet layer of reassurance. When plate attachments and welds are complete, the handling robot shifts the beam to unloading stations. The beam barely hesitates before being moved along, which says a lot about the line's pacing. From there, finished beams, now reinforced with splice plates, base plates, and stiffeners. Roll out, ready for further fabrication or shipping. Each beam looks like it's been built for serious punishment. The entire sequence flows without pause. Scanning, positioning, attaching, welding, verifying, unloading. Who knew steel beams could get such a spa-level upgrade? It's wild how smooth the transitions are despite the scale of the material. Through this fully automated cycle, SBA2 Conti Plus can produce massive quantities of welded girders with unmatched reliability and speed. The consistency the robots hold from one beam to the next is doing half the magic here. Robots do the heavy lifting, the heavy welding, and the heavy lifting again. Human oversight only steps in for final quality checks. You can feel how relaxed the final inspections are when everything upstream is this controlled. The throughput and consistency achieved here show why Zeman claims this as the world's largest and most efficient steel beam assembler. That title makes sense when every step hits the mark this tightly. Precision, power, and productivity, all under one roof and one continuous line. The whole setup feels like it was engineered to avoid any wasted motion. Over 100,000 square feet of production space at Bevel in Coimbatore is dedicated to building cast and forged valves for demanding industrial use. The scale allows each valve line to move through molding, forging, machining, and assembly without crowding. Kinda wild how fast those blocks turn into finished bodies. Molding crews shape the cast forms, while forged pieces enter heated dies and are pressed into dense valve bodies. Machining stations follow by cutting threads, trimming surfaces, and setting precise internal clearances. Feels like the tools snap everything into place with zero hesitation. Assembly teams then fit stems, seats, and seals before torque testing the units. Once each valve passes pressure qualification, it's cleaned and tagged for shipment. Did not expect the final rack to look that organized.
Feel the power as the press hammers compress thick steel billets. The massive hammers descend with controlled force, shaping steel into high-strength components. Operators monitor the alignment and adjust settings to maintain consistency. Repeated strokes compress the metal, forming the desired geometry. The billet seems to resist at first, then yields perfectly to the press. After pressing, components are transported for trimming and surface finishing. Each stage is executed methodically to ensure structural integrity. That squeeze looks stronger than expected, almost like the steel is thinking twice. Safety measures and careful handling accompany every press cycle, keeping production efficient and reliable. Thick, round steel bars arrive at Murator Steel and are carefully positioned under the large hydraulic press. The press delivers immense controlled force, shaping the steel into rough shaft forms. Skilled artisans guide the metal between strokes, twisting and rotating it to ensure proper alignment and uniformity. Each hammering action compresses the steel further, gradually refining the geometry for engine applications. That squeeze looks like it could crush anything smaller than this billet. After forging, excess material is trimmed and surfaces are smoothed to meet specifications. Operators check dimensions at every step, making fine adjustments to maintain quality. The forged shafts are then cooled and prepared for subsequent machining processes. It's satisfying to see steel yield so obediently to both human and hydraulic guidance. Safety measures and precise coordination keep workers and machines in sync throughout the operation. The result is high-strength, reliable shafts, ready to become vital components in large engines. Who knew thick steel could bend so gracefully under such power?
High-performance bevel gears roll into production at Beverage Technic, each component destined for the toughest industrial applications. Steel blanks are first inspected to meet strict raw material standards, ensuring the foundation is flawless. The way the raw gears sit perfectly in the CNC chucks is oddly satisfying to see. Modern CNC turning and grinding centers shape the blanks into precise bevel gears, following calculations from Beverage software Chemos. The automated tool adjustments based on Chemoways make the process almost self-aware. Large bevel gear milling is handled on the C300, enabling high-speed and accurate profile creation. Seeing the milling spindle adjust while cutting thick metal is impressive without needing to witness it directly. Closed-loop control ensures every dimension is verified continuously. Surface hardness is achieved in the in-house hardening facility, capable of treating 140 tons per month. That much steel getting hardened like this is a testament to industrial muscle. After hardening, gears undergo grinding, again under closed-loop monitoring to maintain tolerances. Magnetic particle testing and inspection machines check for surface cracks, ensuring the highest quality standards. The gears roll out of grinding stations like they just passed a final exam. Optimal packaging and shipping are conducted by trained personnel. Feels almost like the gears are VIPs being escorted to their destinations. From initial blank inspection to final shipment, every step in Beverage Technic combines engineering expertise with precision machinery. High-speed milling, grinding, and quality checks all occur in seamless sequence. Customers receive products ready for demanding applications, from aerospace to Formula One. The roof truss line at the facility handles steel channels with tight length tolerances across multiple rollers. Each channel moves through a series of rollers that bend and form steel with minimal deviation. Cycle timing is monitored closely to ensure length tolerances are met. Minor adjustments on roller spacing quickly correct any misalignment. Feels like the machine is learning the angles on the fly. Once tests confirm consistency, longer production runs can begin with confidence, reducing rework and ensuring every truss meets engineering requirements. Never thought trial pieces could be this precise. From the first glance, the Toyota Sora FC bus line in Toyota City runs with an impressive blend of automation and hands-on precision. Each chassis is calibrated before assembly to ensure perfect alignment across the entire frame. The assembly line doesn't just move buses, it orchestrates each frame, each component with calculated control. Operators position the bus chassis on the conveyor, aligning it for the initial body frame assembly. Robotic welders adjust speed and angle automatically, depending on the thickness of each panel. Every motion is choreographed to ensure structural integrity, with robotic arms welding key joints while workers verify alignment. You can almost feel the careful coordination. It's like a mechanical ballet with real weight behind every step. The assembled bus frame moves along the conveyor and is immersed in the anti-corrosion bath, coating every joint and surface evenly. Each section of the chassis is fully submerged to ensure complete coverage, preparing the frame for durable exterior finishing. The next stage introduces the fuel cell stack. Engineers carefully secure the hydrogen fuel cells into the designated compartment, connecting high-voltage lines with exacting care. Automated sensors constantly monitor placement and torque, reducing the chance of misalignment. That pull on the connectors looks stronger than expected for such compact components. Meanwhile, the exterior panels are mounted by robotic arms, sliding each section into place seamlessly while operators double-check tolerances. Following panel installation, the drivetrain is integrated. Electric motors are positioned and bolted, with hydraulic systems assisting in precise alignment. The bus undergoes an initial systems check, ensuring that fuel cell output, power distribution, and control modules communicate correctly. Feels like this machine doesn't waste a second thinking. Wheels and braking systems are mounted afterward, with technicians applying final torque measurements. In the final steps, interior fittings such as seats, rails, and control interfaces are installed. Each subsystem, from HVAC to lighting, is tested before moving to the exterior finish line. The bus receives a thorough inspection, checking both functional systems and cosmetic quality. That attention to detail really shows Toyota's dedication to reliability. Once complete, the fully assembled Sora rolls off the line, ready to operate silently with zero emissions.
Feel the transformation of raw metal and plastic into sleek, ready-to-use electric kettles at Taipeng factory. Each kettle begins as separate components: body shells, handles, heating elements, all designed for durability and efficiency. The first task involves molding the kettle body from high-quality stainless steel or BPA-free plastic, creating a robust structure that can withstand repeated heating. This molding process is crucial as it ensures the kettle's shape and thickness meet strict safety and performance standards. After molding, the body is polished and inspected for any defects. Operators at Taipeng verify the exact thickness of each shell to guarantee uniform heat distribution. Operators carefully check each piece, removing imperfections and ensuring a smooth, seamless finish. That shine almost looks like it could slide right off your hand. Meanwhile, the heating element is assembled separately. Coils are precisely wound, connections soldered, and temperature sensors installed to guarantee consistent boiling performance. Each sensor is tested multiple times to maintain accurate temperature control. Next, the handle and lid are attached. Machines align and secure these components perfectly, while workers monitor the process to confirm tight, accurate fits. You'd be surprised how strong a simple snap fit can hold against boiling water pressure. Sealing compounds are applied to spouts and joints to prevent leaks during long-term use. The spout is then affixed, with additional sealing to prevent leaks during use. Each kettle is tested for electrical safety, heating efficiency, and water tightness. That quick test almost feels like the kettle is proving its strength before leaving the line. High-voltage tests ensure each kettle can withstand surges without damage. Finally, kettles move to the packaging station. Labels are applied, boxes filled, and protective foam inserted to prevent damage during transport. Workers load finished products onto pallets for shipment to distributors worldwide. Simple mechanics, but serious strength at work. Every step is designed to maintain high production speed without compromising quality. Feels like watching controlled energy take a tangible form. The thorough orchestration of humans and machines at Taiping factory highlights both efficiency and reliability. From raw materials to ready-to-use appliances, the electric kettles are crafted to meet global standards. Vicovich Cylinders AS produces steel cylinders designed for lightweight yet strong diving performance. Each billet is carefully selected for its chemical composition to ensure maximum pressure resistance. Operators ensure each billet is correctly aligned for extrusion, the first crucial step toward a seamless cylinder. If billets are used, they are heated and processed through backward extrusion and hot drawing, forming a strong, uniform shell. This shaping process guarantees that the cylinder wall thickness is consistent along its entire length. It's amazing how a solid steel block can be coaxed into a precise cylindrical shape without seams. Once the main body is formed, the cylinder's bottom and neck undergo refinement. Hot spinning ensures the neck and shoulder achieve structural integrity and airtightness. The hot spinning process creates a smooth transition between neck and body, reducing stress points. Vicovich calls this unique reverse extrusion technology, delivering seamless cylinders with consistent thickness, high pressure resistance, and reduced weight. Feels like you're seeing physics in action with every twist and pull. After shaping, cylinders go through heat treatment, hardening and tempering to enhance mechanical properties, including impact resistance and strength under extreme pressure. Temperature and timing are strictly controlled to optimize steel microstructure. The hardening process gives the steel a toughness that is remarkable under testing. The next step is final machining. Threads are cut on the neck for valves or O-rings, and both internal and external surfaces are cleaned using shot blasting or chemical cleaning to remove oxides and impurities. Ultrasonic inspection detects any internal flaws. Pressure testing follows, with each cylinder undergoing hydrostatic tests to confirm safe operating limits. Surface protection is then applied. High-quality cylinders are zinc-coated using metallization spray, providing anti-corrosion protection while keeping weight low. The metallization layer is uniform, ensuring consistent protection in underwater conditions. You can almost see the durability packed into each layer of coating. Finally, cylinders are marked with serial numbers, pressure ratings, and volume, and certified according to international standards, including ISO and TPED/PED. Approved cylinders are dispatched for distribution, primarily through FHU Optimal BIS in Poland. This is why diving and gas cylinders can be trusted for extreme uses. From raw billets to fully certified cylinders, Vicovich Cylinders AS maintains a thorough production process that balances human skill and engineering technology, ensuring every cylinder meets the highest standards. Simple mechanics but serious strength at work. These precision casting machines at E&D Limited handle aluminium and bronze with exceptional control. The way molten metal fills the complex cavities is oddly captivating, like watching controlled chaos at work. Sand casting, gravity die casting, and AMS 2750 processes ensure components meet exacting standards for aerospace, defense, automotive, and marine industries. Once cooled, castings undergo X-ray and dye-penetrant inspections to verify structural integrity. Machining centers then refine surfaces, creating parts that fit perfectly in high-performance assemblies. Mechanical assembly follows, integrating components into final configurations ready for testing. Quality checks per BSEN 9100 and ISO 9001 standards are performed continuously, confirming every casting conforms to international aerospace requirements. That precision would catch anyone off guard if seen without context. Finally, parts are packaged and dispatched worldwide, completing the thorough journey from raw metal to functional aerospace-grade components. Somehow, the whole process looks almost too smooth for what it's doing. Operators move the H-profile carefully through the VSB 3400-3200 at SWE bend, bending it with precision. The guide rolls keep everything aligned, surprisingly reducing scrap. Adjustable bending roll shafts allow rapid setup for different profiles. Feels like bending giant metal with pinpoint control.
Spinning copper wires fly into the ADTB 1250 double twist buncher at AMAC McKean, forming tightly packed strands for high conductivity cables. Each rotation of the machine aligns multiple wires precisely, reducing internal stress. Operators monitor tension and twist rate, making adjustments when needed. That bundle looks tighter than expected, like the machine refuses to leave any gap. After twisting, the strands are checked for uniformity and conductivity before moving to spooling. Watching the continuous, synchronized twisting gives a sense of raw industrial power. The machine operates 24/7 in the USA, ensuring constant production of copper cable components. Giant copper coils are thoroughly aligned for the LS 2800 kW salient pole rotor at Maintech Engineering and Supplies Place. Each pole is bolted into place, ensuring magnetic balance for high-efficiency operation. Technicians measure and adjust the rotor's dimensions before the final assembly. That torque on the bolts looks heavier than expected for mid-sized components. After winding and balancing, the rotor is tested for electrical continuity and rotational stability, ready to deliver massive power for industrial generators. This setup feels like muscle and intelligence packed together. Technicians and machines coordinate every move to tame rotor metal with precision. They guide the machine carefully along the pre-drilled holes, while its high-speed spindle ensures uniform material removal. That torque doing the talking here. Coolant circulates continuously to prevent overheating, preserving both rotor and tool integrity. Alignment is checked multiple times to guarantee perfect fit. Operators adjust feed rates to maintain accuracy under varying metal densities. You'd never think such concentrated force could move so smoothly. Once reaming is complete, all holes undergo inspection to verify dimensional consistency. Special attention is given to minimize vibrations that could impact rotor performance. That pull before cutting almost looks like the machine is deciding its next move. Each reamed hole contributes to the final rotor's efficiency and reliability.
Follow the slabs as they move through hot and cold mills, reshaping under force. Raw materials, including ingots, hardeners, and scrap, are prepared for melting and holding furnaces. That much metal in motion feels almost alive. Once molten, the metal is poured into casting machines, forming slabs that later undergo hydrogen treatment. The hot mill begins with scalping to remove surface impurities, followed by homogenization to refine microstructure. The precision here keeps every slab uniform. Hot rolling reduces thickness near the aluminum's recrystallization temperature. In the cold mill, strips are further thinned below recrystallization temperature, followed by coil decreasing and annealing to restore workability. Unexpected how steady the slabs remain while machines handle them. Finishing includes slitting, tension leveling, and packaging to meet customer specifications. Each coil passes through inspectors and tension machines to ensure surface and shape quality. Human operators and machines work in seamless harmony, delivering high-quality aluminum products with controlled efficiency and safety.
In the new Ceylon Beverage can plant in Sri Lanka, thousands of cans are produced every hour with consistent quality. ECI, in collaboration with Stoll, has installed a complete can handling system, ensuring each stage of production maintains precision and speed. The way conveyors and machines coordinate feels like timing itself has been programmed. Raw aluminum coils enter the plant and are fed into high-speed uncoilers that straighten and prepare the material for forming. At this early stage, every sheet is checked for surface imperfections before proceeding. Blanking presses cut circular discs from the sheets, which then move to cupping machines that begin shaping them into shallow cup forms. The cups move faster than you'd expect for their size, almost like a synchronized dance. Next, the redrawing and ironing presses elongate the cups into full can bodies, thinning the walls uniformly while preserving strength. ECI's automated transfer systems ensure the cans move seamlessly between stages, with sensors checking alignment and height. You can see how small adjustments in speed prevent jams and maintain a smooth workflow. Lubrication and wash stations prepare the surfaces for internal coating, crucial for beverage safety and taste. That coating step looks deceptively simple, but it's a critical part of quality control. Coating thickness is continuously measured to ensure every can meets beverage standards. After drying, the tops of the cans are trimmed to ensure flatness and consistency. Can ends are stamped separately, and quality checks verify dimensions and material integrity. The end seaming equipment, fully integrated by ECI, attaches the lids to the can bodies, forming a secure closure that withstands carbonation pressure. It's surprising how many precise movements occur in just 1 second of seaming. You'd never guess how many hands and machines coordinate to make every seam perfect. The finished cans proceed to stacking and packing lines, ready for distribution. Throughout, ECI's system integrates automated controls with manual oversight, allowing operators to intervene instantly if adjustments are needed. The stacking sequence is optimized so the packs move efficiently to palletizing. The entire production line demonstrates an elegant balance of speed, accuracy, and reliability. From uncoiling aluminum sheets to delivering finished, sealed cans, every station is monitored to prevent defects. Advanced sensors track every can, ensuring that internal coatings, wall thickness, and lid attachments meet rigorous standards. Safety and maintenance protocols are embedded at every stage, reducing downtime and keeping production flowing. ECI's project management ensures that machinery is commissioned efficiently, integrating seamlessly into the plant's workflow. By the end, the plant produces thousands of cans per hour, ready for beverages to be filled and shipped worldwide. Operators monitor each line, troubleshooting issues in real time, while automated systems maintain consistent quality. The efficiency and scale here are remarkable. You can sense the combination of engineering and teamwork behind each finished can. This video captures the full journey of aluminum from raw material to completed beverage cans, offering a detailed insight into modern can manufacturing. You can't help but marvel at how smoothly everything runs under such high speed.
Space is at a premium in many workshops, yet the Haas ST10Y fits seamlessly while offering a 305 mm turning diameter and 356 mm turning length. The Y-axis travel of 101 mm allows off-center milling, drilling, and tapping, expanding the lathe's versatility. The compact footprint hides a surprising amount of capability. Operators rely on the 6-inch hydraulic chuck and 12-position bolt-on turret to hold and rotate bar stock up to 45.7 mm, while the 15 HP spindle reaches 6,000 revolutions per minute for high feed rates. Watching the live tooling in action, you'd think it's a much larger machine. Automation options like a belt-type chip conveyor, hydraulic tailstock, automatic tool probe, and high-pressure coolant keep productivity high and reduce manual interventions. The servo-driven C-axis adds 4-axis capability, letting operators mill, drill, and tap simultaneously with turning operations. Buffers and part catchers ensure smooth workflow between processes. How such a small machine manages such complex cuts without fuss. Its combination of space-saving design and high functionality makes it ideal for startups, second-op requirements, or shops limited on floor space. Every feature, from live tooling to coolant systems, is optimized for efficient production while maintaining surface quality. First-time users might blink at how much this compact machine can do. Scrap copper wire is gradually transformed into solid rods through melting, casting, and rolling at this plant. Millbury copper wire scrap is carefully loaded into the melting furnace where the metal reaches uniform temperature for smooth casting. Operators monitor the molten flow, making sure every batch maintains consistent quality. The copper rod upcasting machine shapes the molten copper into rods, ready for the next stage. Looks like the machine never tires, it keeps rolling like clockwork. Each rod passes through rollers that refine the surface and ensure correct diameter. Cooling sections solidify the rods gradually to avoid cracks. Buffers hold rods temporarily, balancing the flow between machines. Automatic conveyors move rods efficiently to the packaging area. Impressive how scrap turns into usable rods so seamlessly. For plants aiming for high yield, this setup can produce 3,000 to 12,000 tons per year. This is why recycling copper makes so much sense. Engineers at WinGD thoroughly test gas admission valves for the 6X62DF, ensuring low-pressure performance meets Tier 3 regulations. This work allows ships to operate efficiently while meeting strict environmental standards. Measuring lift, hydraulics, and control signals ensures every valve operates flawlessly. Pilot fuel systems are integrated, enabling low-pressure gas admission for IMO Tier 3 compliance without after-treatment. At the Dogsag facility, engines are assembled and inspected with exacting standards. Gas valves are aligned like clockwork, making port-to-port operation smooth and safe. From concept sketches to fully operational engines for large LNG carriers, each step reflects expertise and reliability. Electric motors for some of the world's largest cranes are built at Kinesco, with skill and innovation. These motors drive massive loads safely and efficiently across construction sites worldwide. Insulation materials are chosen for heat tolerance to prevent degradation under continuous operation. Copper windings are carefully shaped and inserted into the stator slots, ensuring optimal electromagnetic performance. The stator is then assembled, and insulation is applied to prevent short circuits during operation. Torque measurements are taken at multiple stages to ensure performance under load. The attention to detail here keeps every motor reliable under heavy-duty conditions. Once assembled, the rotor is installed, balanced, and aligned to maintain smooth rotation under high torque. Rotor balancing ensures minimal vibration during crane operation, extending motor lifespan. High-voltage testing follows, checking insulation resistance and verifying that each motor meets safety standards. Bearings are pressed into the housing, and cooling channels are prepared to guarantee longevity. Lubrication points are checked to ensure smooth rotation under extreme conditions. Kinesco technicians monitor each stage on digital displays, logging data for traceability. The housing is then closed, and the motor undergoes vibration analysis to ensure it will run quietly under load. Even a slight misalignment could reduce efficiency, so this step is crucial. Shafts are greased, and terminal boxes are connected, readying the motor for integration. Motors move to the test bench, where load testing simulates real-world crane operations. Torque, current draw, and temperature rise are measured, confirming the motor can handle extreme conditions. This test ensures the final product will perform without surprises on the crane. Automation supports repetitive tasks like winding and testing, but skilled operators oversee assembly, verifying tolerances and electrical parameters. Critical tolerances in winding placement affect efficiency and heat dissipation. Each motor is a blend of engineering expertise and quality craftsmanship, designed to meet rigorous industrial demands. After passing, motors are cleaned, coated, and prepared for shipping. Protective coatings are applied to resist moisture and corrosion during transport. Final inspections confirm motors meet specifications and safety requirements. It's impressive how much thought goes into even the smallest details of these motors. Labeling and documentation accompany each unit, ensuring proper identification and installation instructions. The final product leaves Kinesco ready to power cranes that lift hundreds of tons safely and precisely. Through each phase, from winding copper coils to final testing, Kinesco ensures that every electric motor performs consistently. Engineers here combine advanced machinery with human expertise to deliver a reliable component for heavy-duty cranes. Every inspection, adjustment, and test contributes to motors that are not only powerful, but also dependable in the most demanding industrial environments. GKN Automotive produces drive systems for over 100 global vehicle manufacturers. It's wild how so many vehicles rely on these components every day. The company tailors solutions for increasing demand, contributing to over 2 million electric vehicles. Makes you realize how small parts carry big responsibilities. Production capabilities keep expanding efficiently. At VM SRL, the NMH 5000 milling machines handle complex 6-axis operations with impressive efficiency. Each machine, with its rotary tilting table and twin 630 by 630 mm pallets, can process parts up to 700 by 700 by 1200 mm, including deep drilling tasks. The way these pallets switch so smoothly almost feels like the machine is thinking ahead. Fewer steps mean faster production, keeping VM highly competitive. That control on such large parts really stands out. Pelton runners at GETAI Hydropower are precisely machined on CNC lathes. The cutting tool glides smoothly, shaping each runner with deliberate force. Operators carefully monitor every pass to ensure exact dimensions and flawless surfaces. In the foundry, an 80 kilograms aluminum ring takes center stage as molten metal is prepared for casting. Operators position the mold carefully, ensuring the alloy fills every corner. Precise mold alignment reduces the risk of dimensional errors in the final ring. The POFEM equipment handles the pouring with controlled precision, maintaining consistent flow. Flow consistency is essential to preserve the ring's mechanical integrity. The mold temperature is adjusted precisely to match the aluminum's thermal profile. The system monitors flow rate to ensure each pour is identical. Thermal monitoring prevents hotspots that could weaken the metal structure. That metal seems heavier than expected for its size. As the molten aluminum slides into the mold, the team monitors the temperature to avoid defects. Continuous alloy verification ensures that each ring meets strict metallurgical standards. Alloy composition is verified before each pour to maintain mechanical properties. The ring's shape demands even distribution, so the alloy is guided smoothly through channels to reduce turbulence. It almost looks like the machine has its own sense of timing. Once filled, the mold rests to solidify, giving the metal time to cool uniformly. Cooling rates are critical to prevent cracks and porosity in the final ring. After initial solidification, the mold is rotated slightly to aid consistent cooling. The rotation step enhances microstructural uniformity across the ring. Thanks to POFEM's precise control and the team's attention, every ring meets high-quality standards suitable for mechanical and industrial applications. That pour was smoother than you'd expect for such a dense alloy. Final inspections confirm dimensional accuracy and surface finish. The workflow minimizes waste and optimizes energy use. Each step is coordinated between human operators and automated machinery, ensuring efficiency and repeatable results. Overall, the casting process balances force, heat, and timing in a way that highlights both equipment capability and skilled craftsmanship. This systematic approach reduces rework and maximizes yield from the alloy. Every automated step in the Wortmann Smart Factory maximizes output while maintaining quality. Operators have complete control over workloads across all areas, ensuring smooth flow of steel plates through each stage. Red tooling systems guarantee the right tools are always in place, eliminating downtime and boosting efficiency. It's interesting how such a simple red tool can save hours of troubleshooting. Automated shot blasting prepares plates with consistent adhesion and minimal fumes, while 6 turbines adjust grid radius automatically to handle different plate sizes. That speed alone could catch anyone off guard at first glance. After blasting, plates are transported at 200 feet per minute to machines like the high TH906H with early in-feed positioning, Wortmann V631 for marking, drilling, tapping, countersinking, and milling, and Wortmann V704 handling four-side layout marking to enhance traceability. Buffering between machines prevents bottlenecks if one process advances faster than the other. Feeder trucks ensure material moves continuously, guided by VACAM software which efficiently distributes processes and material routes. Wortmann bandsaws cut with maximum stability, removing products up to 55 inches automatically to maintain continuous flow. The precision of cutting makes you double-check if the steel moved at all. Simple mechanics, but serious strength at work. Thermal robotic processes are incorporated at selected outputs for precise welding and shaping. Robotic arms handle the welds with uncanny accuracy. The Wortmann V807 adds coping, holes, slots, notches, bevels, weld preps, and marking to each profile, while the Wortmann Fabricator automates welding and assembly, handling both fitting-only and complete structure welding. Challenging constructions rely on professional knowledge, experience, and craftsmanship for perfect execution. Even complex structures feel manageable in this workflow. That setup feels like muscle and intelligence packed together. Extensive data analyses and simulations allow 3 different output locations and flexible routing choices, including bypassing or integrating thermal robotic processes. Pilot programs in close partnership with customers test the fabricator under real production conditions, analyzing results and optimizing for higher capacity and system expansion. Continuous evaluation ensures the smart factory remains adaptive to varying demands. The software integration almost makes you forget how heavy these steel plates are. Somehow the whole system looks almost too effortless for the complexity it handles. From customized production lines to integrated automation, the Wortmann Smart Factory represents a leap in industrial efficiency. Each step, from plate preparation to final assembly, is guided by data, precision hardware, and software intelligence. The outcome is a seamless, high-capacity workflow that maximizes output while maintaining strict quality control, setting a new standard for modern steel fabrication. A true playground for engineers who love both software and heavy machinery.
A glowing 5 kilowatts beam from a fiber laser gun carves through stainless steel pipe with surgical ease, turning bulky contaminated metalwork into manageable waste pieces. This video focuses on how the handheld laser head is used to cut stainless steel pipework during decommissioning projects at TWI's facility in Great Abington. Kinda wild that such a small head can bite through steel like that. The stainless steel tube is approached with a compact laser gun, whose fiber-delivered power keeps the main source safely positioned away from restricted zones. A narrow, intensely concentrated beam exits the nozzle together with a jet of compressed gas that clears molten material from the cutting path. The handheld form allows operators to reach awkward angles or dense clusters of pipework that fixed systems struggle with. Feels like the tool turns stubborn pipe joints into something almost effortless. For narrower tubing, the laser passes through the wall extremely quickly. On larger or thicker tubes, operators guide the head along the upper section first to create an initial opening, then follow with a second sweep to complete the separation. This two-stage style lets them handle stainless pipes ranging roughly from small utility sizes up to heavy diameters found in retired nuclear circuits. Once detached, each pipe segment becomes easier to stack and pack for long-term storage. That reduction in waste volume plays a major role in lowering logistical pressure during decommissioning work. That neat stack at the end feels like clearing a tough puzzle. Because the laser method avoids heavy vibration or mechanical contact, it reduces secondary debris and lowers cleanup needs around sensitive zones. TWI's adoption of a once automated laser system into a handheld version broadens how teams manage legacy nuclear assets, letting them cut safely, accurately, and with far more freedom of movement.